Okay, so for example number 1 here, okay, we have 250 grams of water. So they told us first off that M is 250 grams and that it's water. So we can calculate big M. All right, so H2O is going to be 1.01 times 2 plus 16. So the molar mass will be 18.02 grams per mole. All right, so we would get 1 mark for that step. How many moles do we have? All right. So N equals little m over big M. And N stands for number of moles. So we don't have to do any manipulating. We just need to plug in the numbers we have. 250 grams divided by 18.02 grams per mole. The grams will cancel off and we'll be left with moles. So 250 divided by 18.02 will give us 13.87 moles. Questions on that one? Okay, those are pretty straightforward. Yeah, give you a couple minutes before I do number 2. Okay, so for number 2, we've got 27.25 moles of calcium bromide. So what did they give us? Okay, which is which letter? N. Okay, so we got N is 27.25 moles. And they told us it's calcium bromide. So that's CaBr, but we got to drop and swap. This is a -1, that's a +2. Okay, and guys, that's crucial. If you forget to do that, will you get the molar mass right? And you'll get everything else in the question wrong after that. Okay, so really all I can do is generously give you 1 mark for your givens and maybe a mark for manipulating the formula correctly. Okay, and that's it. Because if you don't get that first and most important step correct, the rest of your numbers will be wrong. Okay, so we got 40.08, okay, plus 79.9 times 2. 40, oh, works better when it's on. 40.08 plus 79.9 times 2. Okay, it's 199.88. Yeah. Grams per mole. All right. So I've got N and I've got big M, and I'm looking for the mass of that much stuff. All right. So N equals little m over big M. Do I need Avogadro's number for this question? Nope. Okay. There's nothing here about molecules, so I don't need it. Okay. So I've got to take my big M here and move it over to the other side by multiplying. Okay. So I would get a mark for that, a mark for givens. Then plug in my numbers. M equals 199.88 times 27.25. Whoop, not 0.02, 0.25. Okay, so we're going to have 5,446.73. 0.73 what? Grams. Okay, so you get a mark for manipulating, mark for plugging, mark for your answer, 4 marks. Questions on number 2? Okay. All right, in this one, I am given something about molecules. All right, so in this case, I'm given the number of molecules. Will I need Avogadro's number this time? Yes, I will. Okay, what am I going to do with it? All right, I'm going to divide by it because I'm given the number of molecules. Avogadro's number is the number of molecules in 1 mole. So if I divide those 2 numbers, I'll be left with the number of moles. All right, so why don't we do that first? Okay, we'll find what N is by going 4.5 times 10 to the 25, the number of molecules, divided by Avogadro's number, the number of molecules in 1 mole. And that'll give us our number of moles. Okay, so there's the number of molecules we had divided by Avogadro's number. All right, so we have 74.75, and what am I going to do with all these decimals? I'm going to keep them. We talked about this yesterday. Okay, we want to keep them and round at the end of the question. All right, so I'm going to keep all those. I'm not going to write them all. I'm just going to keep them all. 74.75 moles. Okay, but I'm keeping all those decimals in my calculator to use later. All right, so I've got that. The other thing they tell me is that this stuff is lithium sulfide, which will help me to get capital M. Okay, Li with S, this is a -2, that's a +1. So we're looking at Li2S. So that's 6.94 grams per mole times 2, because there's 2 of them, plus 32.07 R1 sulfur. Is that right? 32.07? Okay. Okay, so 6.94 times 2 plus 32.07. Okay, it's 45.95 grams per mole. Okay, I now have N and I have big M. So can I calculate the number or the mass of this stuff now? Okay, but I have to manipulate the mole equation before I can do that. So little m over big M, multiply both sides by M. Okay, so little m equals 45.95 times our 74.75, but we'll use all of the decimals when we do this actual calculation. Okay, so we're going to take our answer and we're going to multiply it by 74.75083056. Okay, so I'm going to have 3,434.80 grams. Yeah. Yeah. I didn't see it. Oh, but then you got to write it all down. Yeah. You can usually save, just go M plus. Even on non-scientific, they should have at least the ability to enter one number into memory. Okay, so if you have that number, go M plus. It'll put it in memory. Then then get your other stuff, and then go RM, and it'll recall the memory. That's, yeah, I know. You guys weren't to the generation where that was like the fanciest thing a calculator did back in my day. You could store a number in it, and it would remember it unless it shut off. Yeah, and Tetris was huge. Okay, Tetris was huge. All right, questions on that one? Okay, how many people have done number 4? All right, okay, let's go over number 4 then. Or do we need a minute or two? Minute or two, okay. So on number 4, I'm being asked to calculate the number of molecules. I'm being given the mass and I'm being given the material. Okay, so first off, I know mass, 500 grams. Okay, and I know the material, it is potassium carbonate. So that is K with CO3, which is an ionic compound. So this is a -2 and this is a +1. So we're looking at K2CO3. All right, so I can remember potassium is 39.10. And there's 2 of it. Okay, how many carbon are there? How many? 1. Okay, plus 12.01, and then 3 oxygens. Okay, so 39.10 times 2 plus 12.01 plus 48. Okay, so 138.21 grams per mole. All right, so that's what we got there. Now I need to calculate what? What can I calculate with these 2 numbers here? N, all right, the number of moles. Okay, so N equals little m over big M, so that'll be 500 grams, the mass they gave me, divided by the molar mass I just calculated, 138.21 grams per mole. Okay, the grams will cancel. I'll be left with moles. So I have 3.617, I'm just going to write 3.62, but I'm going to keep all of those moles. All right. Now that I know the number of moles, I need Avogadro's number, because Avogadro's number tells me the number of particles in a mole, in this case molecules. How will I use those 2 numbers together? I will multiply them, okay? Because I have the number of moles, and Avogadro's number is the number in 1 mole. When I multiply them together, I get the number of molecules, because moles will cancel, okay? So, to get the number of molecules, Okay, that's going to be 3.62, the number of moles, okay, but with all the decimals that I had there, okay, times 6.02 times 10 to the 23. All right, so keeping all of those, okay, multiplied by, in bracket, 6.02 E23. All right, so I have 2.18 times 10 to the 24 molecules. Okay, and that one is a 4-mark one, okay, because we got givens, we've got this calculation, then we've got this calculation, and the answer. All right, questions on number 4. I did them a little bit out of order this time, right? I did the 5-mark one third this time. I'm switching things up on you. I don't want you to think they're going to go in order on the unit exam, okay, because they probably won't. They don't. Okay. All right, so let's keep working on the stoichiometry worksheet there. Okay, again, it's similar problems, but now they're more real world. So being able to read a question that actually has more than just do this calculation with these numbers. Okay, it's okay, this reaction's going on, or there's this much of this thing. Okay, so you have to read into the question a little bit more, which is an important skill because reading comprehension is really important when you get to the diploma exams and all the sciences, okay, in grade 12. Last year on the physics diploma, they made kids read 2.5 pages of text to answer 2 questions. It was redonkulous. So being able to read and get everything out of the reading is important. Okay, so for number 8, we have to set this up because it's an actual full reaction. So we're just gonna take a little clip of that. Okay, so here's what we got. We got a reaction that goes like this. H2O is going to break down into H2 and O2. Everybody all right with that? Okay. Now, on this side, when we balance this reaction, we have to have a 2 here and a 2 there to make it work. Okay. We're told that there's 4.5 grams of water, okay, in this material, or in this reaction. There's 4.5 grams of water. How many moles of water is that? Well, it's not necessarily 2 moles. This doesn't necessarily mean 2 moles. This means that there's twice as many moles of water as there are of oxygen. Okay, on the other side. What's that? Yeah. Okay, so what we got to do is we got to figure out how many moles there are. We know the mass of the water, okay, and we know the molar mass of water is 18.02 grams per mole. Okay, so we can figure out how many moles of water are on this side of the equation. Is everyone all right with that? Okay. So we're going to do that. Okay. Okay, so number of moles is going to be 4.5 divided by 18.02. All right, so I have we'll say 0.25 moles, okay, but we'll keep all these decimals. So we got 0.25 moles. I think that's what I meant it to come out as when I did this. All right, since there's 0.25 moles of water on this side, and I have a 2 in front of water, I must also have 0.25 moles of this stuff because they're present in the same ratio on this side. Okay, they're both a 2. Everybody follow me there? Okay, so 0.25 moles over here. Now I have half as much of this stuff. Agreed? So what's half of this number? 0.125. Okay, with me there? Okay, all I'm using here is that I have to have the same ratio of stuff on both sides because they have the same. Okay, now here's the thing we can check. We can check our math and make sure that this comes out to 4.5 grams on that side. Everybody follow? This is what you're going to do in Chem 20, is reaction stoichiometry. Okay, so the molar mass of H2 is 2.02 grams per mole. Everyone all right with that? Okay, and the molar mass of this stuff is 32 grams per mole. Can I calculate how much in terms of mass I have of both of them. Okay. All right, so I'm going to keep this number here because I want to keep all my decimals to be perfectly accurate. Okay, I'm going to multiply that by 2.02. All right, so that says I have 0.50 grams on this side. Okay, so I've got 0.5 grams of hydrogen, and then I got to do the same thing over here. Okay, I'm going to multiply my 32 by 0.125. Oh, yeah, I love it when things work out. How many grams of oxygen do I have? 4. Okay, so I got 4 grams of oxygen, I got half a gram of hydrogen, and over here I had 4.5 grams of water. Law of conservation of mass, obeyed. You won't have to do that till Chem 20. If you're looking at that and going, I don't know, don't worry, you won't have to do it till Chem 20. But I did take the 2 into account. Okay, when I said this, like there's 4.5 grams of this. Okay, I didn't say that meant that there were 2 moles. It means that I have as many, well, I don't want to say moles, but I have the same, let's say, ratio of, right, because they match up, right? So if I had 0.25 moles over here, I have 0.25 moles over here because they're the same number. This one here is only a 1, so it's half of 0.25. What's that? Well, but you can make it work, right? If this had been like this was a 2 and this was a 3, then I would say I have 1.5 times as much of this stuff. So I would go 0.25 times 1.5, and that would have the number of moles over here, right? Right. No, I have 0.25 moles of water. That's a bigger molecule, right? I have 0.25 moles of hydrogen, but remember, that's a smaller molecule, only has a hydrogen there, okay? The most important thing here is not that I conserve the moles, which I also did, but that I conserve the mass, right? I don't have to necessarily conserve moles per se because that's not the same stuff over here, right? So I don't have to worry about the fact that, yeah, it looks like I have less moles. I do, but that's because I broke it up into 2 things. I still have the same mass, and that's what's most important. I would also have the same number of atoms on both sides. Yes. Yeah. Okay. Like I'm never going to ask you to do that in Science 10, but that's where you're headed. Okay. You're going to use the mole equation a whole bunch of times in one reaction to figure out the mass of everything. If you recall, I told you that the first day. Okay. That's kind of where this is headed. 6 here. So I've got 0.6 moles. So I know what N is. It's 0.6. And I'm looking for mass. I need to get the molar mass of iron hydroxide, iron 2 hydroxide. Okay, so that'll be 55.85 plus 32 plus 2.02. Okay, so there's my molar mass of iron 2 hydroxide. I'm going to multiply that by my number of moles, which was 0.6. Okay, and I got 53 grams, which is, I think, what the answer was, right? Yeah. That makes sense? So there's a lot of, this is kind of teaching you to weed out what's important and what's not important. All right, so number 12, similar thing. Lots of extraneous information, okay, that we don't really need. Okay, how many moles of zinc reacted? Okay, so here's what we have to do. Here's my final mass of zinc. Here's my initial mass of zinc. Whatever the difference is how much of it reacted, right? Because this was how much I had left over, the 14.84. Everybody follow there? So if I go 16.58 minus 14.84, I'll know the mass of zinc that was used up in the reaction. Okay, so that's my first step. So I'll go 16.58 minus 14.84. Okay, so I used up 1.74 grams of zinc in this reaction. That's my mass, okay, for this question, 1.74 grams. Now, because it's just zinc, I can go to the periodic table, get the molar mass of zinc. It's 65.39. Okay, so now if I want to calculate the number of moles, I'm going to take my mass and divide it by 63.59 grams per mole. Is that right? 65.39, sorry. 65.39? Okay, I had it backwards. Okay, so 0.027 moles reacted. Okay, does that make sense? That's a tricky one, right? I'm adding in just an extra step just to see how closely you're paying attention. Okay, any other ones? Okay, keep it going there, guys.